Hello, my name is Michaela Buchanan and I am a data scientist at Mark III Systems. Today I will be giving you a quick overview of some of the key features of the Converge I/O platform. Through this demo, I'll be showing you three of the biggest strengths of using Converge in your data science workflow. The first strength is the ability to quickly and easily test different algorithms on your dataset to get a sense for what works and what direction to take your research in. Second, once you have a trained model, it is very easy to deploy a model for real-world testing without any UI development overhead through the Converge platform. The final strength I will be covering is how all the components you need for every step of the data science pipeline is incorporated into one cohesive environment. So let's start by training some models. To do this, I'll be using the Titanic dataset from a deep learning competition website called Kaggle. This dataset is made up of various data points about the passengers that were aboard the Titanic, and our goal is to predict the rightmost column, which shows if the passenger survived or not based on other information we have about each passenger. Here you can see what a dataset looks like once it's been uploaded to Converge. Uploading datasets is very straightforward. You can drag and drop files from your local machine into the dataset, or if you have larger files, you will need to use the CLI provided by Converge. However, this is also quite easy to do, and some might actually prefer the command line-based approach anyway. One of the nice features of the Converge datasets is a built-in version control system. For example, here you can see the commits that were made after every change I made to this dataset. Many projects involve manipulating your data to make it easier to train off of, and being able to revert back to an earlier version of the dataset can be very helpful if you make a mistake during this step. As you can see here, I could just revert back to this commit if I wanted to, very easily with just a push of a button. I also wanted to point out the privacy feature of Converge datasets. This dataset is currently set to private, which means I'm the only one who is able to access this data. This is great for situations where you don't want anyone else to be able to change your datasets, or if only certain individuals are permitted to see the information due to legal restrictions. We can also set the dataset to public, like this. This would allow anyone in our organization to be able to see and use the dataset. However, even when it's set in private, you can still invite team members to work with you on a dataset. To do this, you go to Collaborators, click Add, and then if I wanted to add my coworker Tim to this dataset, I'd just find him right here and hit Submit, and then he'd be able to access and see the dataset just like I can. Okay, now we're ready to begin pre-processing our data so we can use it for training. To do this, I'm going to use what Converge calls a workspace. Let me show you where that is here. So a workspace allocates a specified amount of computing resources for you to use. For example, you can use a small or medium allocation if you're just poking around at the data, but for more intensive tasks, you might want to use a larger or a GPU-enabled compute allocation. These compute resources can come from the hardware you own, which has been integrated into Converge, cloud computing resources, or a combination of both. You can also see the fully integrated data science flow created by Converge I mentioned earlier come into play here, as it's very easy to incorporate the dataset we created earlier into our workspace. You can even select which commit you want to use in the workspace. For example, if I wanted to use this one, I would just click here, and then it'd have the oldest version of the Titanic dataset. We're just going to use the latest one here. We can also specify the container the workspace uses to better fit the task we are trying to accomplish. So for example, Converge already has some NVIDIA containers loaded in here that use PyTorch or TensorFlow or TensorRT or Rapids, depending on what kind of work you're trying to do. And then you can also take containers from sources like Docker Hub and incorporate them into Converge. For example, here I have one that has both the transformers and the PyTorch library ready for me. So if I want to do some natural language processing and I need those libraries, I don't have to download them. I can just use this container to spin up my workspace. Finally, you can specify what type of workspace you would like to work in. You can use a Jupyter Lab instance, which lets you work in Jupyter notebooks, an RStudio instance if you prefer R, or a Visual Studio IDE. Instead of starting a workspace at this moment, I'm going to actually show you one I already have spun up so you can get an idea of what it looks like. So we're going to click on here. This will just take a second for it to spin up the Jupyter Lab instance. And here you can see my pre-processing notebook that I have here in Converge. And this line shows how easy it is to incorporate the dataset that I brought into this workspace. It is all located in the data directory, and you just pull in the file you want to work with, which for me was the train CSV file. Then here you can see all the pre-processing work I did to this information. And then when I was done, all I had to do was save it to a file, and then put it back into my dataset. And it's available for me to use later on. Okay, now we're ready to do some training. While we could continue to do this work in our workspace for the rest of the project, I'm going to show you a tool called Flows, which makes it easy to experiment with different algorithms in parallel. So I'm going to move over here. And here's an example of what a flow might look like. The way this works is you select tasks from over here, and Converge already has a lot for common algorithms you might encounter and want to try available. You can also do custom tasks for scripts you have written that you want to incorporate into this. So over here I have the Titanic dataset that I made earlier, and I'm bringing in the latest version of that. And then we have three different algorithms here. We have XGBoost, we have support vector machines, and we have the random forest algorithm. So if I hit play here, it would actually use the data we have and run an instance of each of these, and then we'd be able to look at the results and compare them. Another cool feature about flows is if I click here on XGBoost, you can see all the parameters that you can change for that algorithm. And then here for the learning rate, I actually have three different values specified. And what Converge is actually going to do here is it's going to recognize those as separate parameters, and it's going to run XGBoost 3 times, and each time with a different learning rate. So you can see how that affects performance. So when we hit play here, we're actually going to see 5 different algorithms spin up. We're going to see our 3 different learning rates of XGBoost. We're going to see the SVM and the random forest. So if I click here at run, we can see we're expecting 5 experiments, which seems right. And we're going to hit run here. And here you can see all the experiments starting to spin up. So if we click on one of these, you can see all the parameters we specified right here, as well as some log output for what it's actually trying to do on the machine, which is very helpful for if you run into errors. It'll actually show them right here. So these experiments are actually going to take a few minutes. So in the meantime, let's take a look at how to serve a trained model using Converge. For this, we're going to move to my natural language processing demo project, which is right here, so I can show you how this works. In this example, I will be using a model called GPT-2, which takes a few words as input and tries to generate text based on your output. So here I'm going to show you the file I used to do that. And the most important part of the file here is this predict function, which we're actually going to call on later for our serving. So we set up our model right here. And then to predict, we just take in our text and we return back our output,